Hi Algebra 2 students, this is video number 5 for lesson 6-2. So we're going to do example 5 and hopefully maybe example 7. So example 5, we have 3 parts here. This third part should say C. And in all of these, we're depositing $1,100 into an account that pays this percent. So right away, I'm going to divide my percent by 100, and that will be the percent I use in my problem. Notice this says compounded continuously, so that means I'm using the PERT formula. And it's saying, what is your balance after 12 years have passed? So this is my time. So they're asking for my ending balance. This is my starting balance. My principal, my initial amount is $1,100. So what am I solving for? I'm solving for A, which is my final amount. So if I think about my formula here, A is what I don't know, P is my initial amount, and then E is the button on the calculator, to the power of 0.55 times T, which is 12. So remember, when you're solving for A, you can put the whole thing in the calculator, which I'll do right now. So 1,100. Remember, E always goes with the natural log button. So I'm going to do second natural log. It jumps it right up to an exponent. So 0.055 times 12, close my parenthesis, and hit enter. And I get $2,128.27, so that sounds reasonable if I started with 1,100. So there we go. Don't forget your units. Story problem requires a story answer. So in this case, those are dollars, so you need a dollar sign. Okay, part B, right away I notice this says how long. So I want you to make a note when it says how long. We're going to solve this by graphing in Desmos. Okay, so it's the similar equation to here, but what we're solving for is our time. So what we're solving for is T. Whenever it says how long, we're solving for T. So the equation's going to look like this, 1,100 e to the 0.055, all that's the same, times T. And the question we're asking is, how long will it take until our final amount is $2,000? So you can think, when you think about graphing on Desmos or anything, you have your X and your Y. Your X is your input, your Y is your output. So for this example, our input is T, or years. The longer you leave your money in the bank, the bigger your final amount, or your dollars, will be. So our input is years, our output is dollars. So they're asking how many years until we get 2,000. So this is what we want to put in Desmos. Now, one thing you want to note is that Desmos doesn't let you change calculators, so we're going to have to put an X in there. So I have Desmos open. I'm going to go ahead and type it in, and then I'm going to show it to you. Bear with me while I move my phone around here. So here's Desmos. This is what I'm typing in, just the right side of my equation. So there's my initial amount, there's my interest rate, and you can't put T in Desmos, so you're going to have to put X in there. Now when I go over here, I don't see anything, but I need to zoom out. So there's my graph. So what this question is asking is, when will my output, my Y value here, be at 2,000? The easiest way to do that is to use your table. So you want to choose this gear and then choose the icon that looks like a table. And you can see when I start, when time is 0, it's $1,100. That is what I put in initially. This means after 1 year, I have this much, 1,162. After 2 years, I have this much. So I'm trying to get to 2,000, so I'm just gonna guess here and put in 10. Ooh, that's pretty close to 2,000, not quite. So I'm gonna put in 11. There we go, I'm at 2,000. So this tells me that sometime between 10 and 11 years, I will have 2,000. I don't know exactly when I hit 2,000 in here, but I do know it's between 10 and 11 years. So the way I'm gonna answer this is, let my phone focus here. This is gonna be between 10 and 11 years. So you need units. When we're solving for how long, your units will be time, and in this case, years. Okay, the third part says, how much should you invest today? So this sounds like, how much is my starting amount? So that's what the question is asking. And in our formula, our starting amount is P. Remember, it stands for principal. In order for you to have $3,000 in 12 years. So this is asking, hey, if you want $3,000 and you can save for 12 years, what do you need to put in the bank today? So my A is 3,000. That's where I'm headed, my final amount. My initial amount, I don't know. So just write that as P. E is the number on the calculator. The interest rate is the same, 0.055. And the years is 12. So now I'm solving for this. That is my variable, right? P. This is just a number. I could, as a matter of fact, put this in the calculator, but if I have a variable times a number and I want the variable by itself, these two are multiplied, so I'm going to divide both sides by this number. And on the right side of my equal sign here, e to the power of that divided by itself, those will divide to give me 1, or those will 1 out. So I'm going to have P equals all of this. All of that I can put in the calculator. It's just a number. So I'm going to put in 3,000 divided by E, so second natural log, 0.055 times 12, right parenthesis. And it says I should start out with $1,550. That makes sense. $550, and it looks like 55 cents. So if I put this much in the bank, in 12 years, I'll have 3,000. So that is solving for your initial amount. So we solved for just about everything here except for R. We solved for A, we solved for T, and we solved for P. So I want you to try this your turn on your own, and I will tell you this is what you should get for part A, $709.53, and part B, this is going to take between 65 and 66 years. So this one, where it's how long, you're going to use Desmos to solve that. Okay, let's take a look at example 7. 7 says the population of Evans City is currently 48,500 and is declining at a rate of this every year. I'm going to divide that by 100 right now. So that would be what I work with. You can model the population in Evans City using this. This looks a lot like PERT, right? They're just putting this little subscript C on here, but this is P e to the RT. So this is telling me population, for some reason in this town, is growing exponentially. And they say P sub C is the current population, and P sub T is the population after T years. So this is your final or your ending population, and this is your starting, just like we're used to. Predict the population of Evans City after 25 years. So that sounds like T is 25. So it says, careful, R is negative because you're declining. This is important. It said declining. So the way we do declining is we want to make this R right here, that's our R, we want to make it negative. So I'm going to recopy this formula they have here. P sub T equals P sub C e to the RT. So we know what we're starting at. The current population is 48,500. E is the button on your calculator. R, because we're declining, we're going to make that negative. So negative 0.025 times 25. So e to the R times T. There's our R, there's our T, our R is negative. And this final amount is what we're solving for. Again, we can put that whole line in our calculator. So I'm going to put in 48,500. Second natural log to get my E to the negative. Make sure you use this button for negative, not the minus sign. 0.025 times 25 years, right parenthesis. Okay, it should be less than what I started with. Looks like it is. Looks like it's 25,960. I'm not going to put a decimal on this because these are people. And it doesn't make sense to have a partial person. So this is, if the population keeps declining, this is what it will be at in 25 years. Okay, this one, example 8 is all together. 6-1 and 6-2, all together. So we're going to have to read carefully. You're putting $5,000 in the bank in all of these cases. So option 1 pays 4% annual interest compounded monthly. So this tells me I'm using this formula. A equals P to the 1 plus R over N to the NT. If you've forgotten these formulas, flip back to the front page where they all are. But this is the compounding one when you're given periods. So this monthly means N is 12. Time is 2 years. Our interest rate is 0.04, so I did 4% divided by 100. So we can just plug this in, starting with $5,000, right? That's our initial rate. 1 and plus is a copy job. R is 0.04, 4% written as a decimal, divided by N, our N is 12. To the power of N, so that's 12 again, times T is 2 years, times 2 years. Now this is the one where I recommended maybe you do this part separately in your calculator. So I'm just going to do the 0.04 divided by 12, and I get 0.00333333. So now I have 5,000. 1 plus 0.00, I'll throw a bunch of 3's in there, to the 12 times 2 is 24. Now this whole line I can punch in the calculator all together. So $5,000, parenthesis, 1 plus 0.00, put some 3's in there, right parenthesis, exponent, 24. And I get $5,415 and this looks like about 67 cents. Now I want to warn you, you might get a slightly different answer depending on how many digits you take this decimal to. Okay, so if you should be close. You should be pretty close to this number, But like 5,411, if you chopped it off here, you might have 5,411. You should definitely have the 5,000 and the 400 should be the same. All right, what's happening in part B? Right there, I underlined it for you, compounding continuously. So that tells me I'm using PERT. So my initial amount is going to be 5,000 in all of these. I'm depositing 5,000 in the bank. This time I'm going to use the E, the number on my calculator. The interest rate is still 4%, so 0.04 as a decimal. And the time is still, the time is 2 years. Okay, now this one I can punch the whole line in at once, and I'm going to use that E. So $5,000 times E, so I can do second natural log, gives me the E, gives me the exponent. 0.04 is my interest rate as a decimal, times 2 years. Okay, so I get 5,416. So I'm going to continue this over here. $5,416.44. Don't forget your dollar sign. Okay, so slightly more than here, which should be, continuous compounding should always give you more money, assuming your interest rate and your time is the same like it is in that problem. And that's what part C asks. What is the difference between the two options after, this asks, cross that out, make that a 2. That should be after 2 years. So the difference would be take your $5,416.44, your answer from part B, subtract your answer from part A, whatever it is. Remember, it might be slightly different. So I'm going to do 5416.44 minus 5415.67, and looks like about $1. Well, not really, 77 cents, I should say. So this says option 2 with the continuous compounding pays more. It pays 77 cents more, which continuous compounding always should. So this said, how would your answer change if you invested $50,000? So I'm gonna actually let you do this one on your own. So for option 1, everything will be the same as it was up here, except you're gonna start with 50,000. So actually you could go right here and plug in 50,000. And then for option 2, you're going to do everything the same as you did in part B. So option 1 is part A, option 2 is part B. So you're going to do everything the same here, except you're going to start with $50,000. And what you should get for this one is $54,113.98. Remember, this might vary depending on where you round your decimal to. And over here, you should get $54,164.35. But you should try these on your own, and you can see there's a much bigger difference here when you're investing more money. That is it.